Let's do some casting back and forth between base and derived and see where that gets us to. Here's some code, again using person and tweeter, and I'll just show you that in person, the getName function is virtual. So that here, when you see calls in main to getName, you know that we're expecting to get the tweeter version if the pointer really points to a tweeter object, and the person version when the pointer really points to a person object, regardless of the type of the pointer. So you can see what's happening here. I'm going to create a tweeter on the stack, make a person pointer by taking its address, and then I'm trying to take a tweeter pointer by just using the person pointer. And I have wigglies here. A value of type person star cannot be used to initialize an entity of type tweeter star. And in fact, if I build this code, I'm going to get an actually pretty insightful error message which says cast from base to derived requires dynamic cast or static cast. I'm trying to go from the base person to the derived tweeter. Now we can see that's true because we know that person's pointing to T, which is really a tweeter, so we know this is safe. But the compiler is not so sure. Now, one way around this, I can use the round bracket cast. Red wigglies go away, and this code will run. And I get the tweeter version with the Twitter handle. So like, woo, I win. I used round bracket casting and I lived. It doesn't really explain our intent, and it can really hurt you. Let me show you how this can really hurt you. I'm going to declare an integer. And then I'm going to declare a tweeter pointer, pointer to I, is equal to, hey, cast this to a tweeter pointer, would ya? The address of I. Compiler's like, well, I guess you know what you're doing. You said round bracket cast, which means get off my case. I know what I want. So let's just copy this line. Only instead of PT, we'll use PI, our freshly minted tweeter pointer that's pointing to a supposedly tweeter. I guess you know this is not going to end well. Boom. And of course it goes boom. Right? I mean, I is not a tweeter. It doesn't have an implementation of getName. It doesn't have a first name, a last name, a Twitter handle, anything. There's no way this could possibly work. But I said that I knew what I was doing. That's why we say sometimes that if C++ had a motto, it would be, well, you're the programmer. Or when we're feeling really kind of darker humor, it's your foot. Yeah, you sure you want me to pull this trigger? Okay. It's not my foot, it's your foot. And as the programmer, I don't want to shoot my foot off, even though the compiler will let me. So why use round brackets which don't check anything? Let's instead use a static cast. So up here, with a good one, I say static underscore cast, angle brackets, I want to cast it to a tweeter pointer, and then I put round brackets around the thing I want to cast. My angle brackets the wrong direction. There we go. Static cast to a tweeter pointer, P. Let's try that down here. Static cast to a tweeter pointer, address of I. No red wigglies here. Red wigglies here. Invalid type conversion. Let's try to build. Types pointed to are unrelated. Yes, that's exactly the problem. So this was a really stupid piece of code to write, and you know what? Using static cast saved me from myself and told me, wow, that was stupid. Why did you want to do that? So static cast will save me from myself. Sometimes what people would like to do is try a dynamic cast instead. Now, the dynamic cast won't object at compile time. What it'll do is if it can't make the conversion, it will give you back a null pointer, which you can test. You notice I'm getting wiggles here. That's because you can't use a dynamic cast with a fundamental type like int, or even with certain kinds of classes. The class has to have a virtual function. So I have good old resource in here. This is a handy class to keep kicking around, and it has a virtual function. So I can try to cast a resource to a tweeter, which would still be pretty catastrophic. So I'll create myself a local resource, passing local into the constructor. And so I'll still try to dynamically cast to a tweeter, but I'll use the address of this resource F instead of my integer. Let's try running. First I'll build it. Compiles without complaint. So when I tried to do static cast between totally unrelated types, I got an error message. Try to do dynamic cast, I'm like, haha, I got away with something, eh? So let's run it. It turns out I didn't really get away with it. And you know, this is why I say that the compiler is your friend. I would rather get my error messages as red wigglies right while I'm typing code, or at least as compiler error messages when I try to build, than after I run. Especially for a real app that takes a long time to run. These console apps just spin right up, but you have some big complicated GUI, you had to click 6 buttons to do a test case, choose things from drop-downs, wait while database connections go through, and then it goes boom. I would much rather get my problem pointed out to me, handed to me by the compiler. That said, I can prevent it from blowing up at all, because I told you, when a dynamic cast fails, you get back a null pointer. So I can take the bad behavior and say, if PI, in other words, if it's a true value, then I will try to call its getName. I successfully converted it to a tweeter. Great, I'll call a tweeter code on it. Else, I'll say something else like resource can't be cast to tweeter. Let's run that. Not surprisingly, it says resource can't be cast to tweeter. But let's recap. When we used round bracket casting, I could cast integers to tweeters and make my app blow up. When I used static casting, it was just as sweet and useful for the good, proper, appropriate casting. We all know here that P really is pointing to a tweeter, so this is an appropriate cast. Everything went swimmingly well. The static cast refused to let me cast between integers and tweeters or between resources and tweeters. Dynamic cast didn't give me a compile error and gave me a way to check at runtime to make sure that this was okay to do. So if someone's going to hand you a pointer or a reference and you're not sure whether or not it's maybe one of the derived types, you can try casting it using the dynamic cast. And if it works, great. It really is the derived class and you can go ahead and call methods on it. Doesn't work? No harm done, just don't do the work. That's how static cast and dynamic cast can save you from yourself, and they're what you should be using instead of round bracket cast.